I'm O. This video shows you the analysis of truss using method of joint. There are two assumptions used in the truss analysis. First, the members are joined together by smooth pins. Second, all loadings are applied at the joints. Hence, each truss member has only axial force. There is no moment as the internal forces of truss. There are general procedures in the method of joint. We need to draw each joint's free body diagram. Start from a joint with least unknowns, not more than 2. Always assume the unknown member forces acting on the joint's free body diagram to be in tension. Apply the equilibrium equations, the summation fx and summation fy equal to 0. This may yield two algebraic equations that can be solved for the two unknowns. The solution gives positive scalars for members in tension and negative for those in compression. Here I would like to share a problem from Hibbler. In this problem, we are required to determine the axial forces of the truss by using method of joint. The truss is being supported at A and roller at E and subjected to 2-point loadings as shown. We can firstly determine the support reactions. Note that the lengths of A and B are required. These lengths can be determined by using the relationship between the shaded triangles. You need to resolve the diagonal force at 100 kN into x and y axes, the axes that you are working on. Once you have solved for the lengths A and B, we can apply the equilibrium equations. Summation m, summation fx, and summation fy in solving for the support reactions. Here we start with taking the summation moment at A equal to 0 and assume positive in clockwise direction. Once the support reactions were solved, we need to observe the forces at all the joints and start the analysis at the joint with the least unknowns. Here, joint A was chosen. We need to draw the free body diagram of the joint A. We assume all the unknown forces in tension, which we will draw the arrow outward from the joint. It is good for you to recheck all the forces has been drawn in the diagram, and do not forget to include the support reactions. Then, we will apply the equilibrium equations, summation fy and summation fx, to solve for the forces. At joint A, two simultaneous equations are yielded and can be solved as shown. Note that FAB is negative, which also denotes this is a compressive force. Once all the unknown forces at joint A were solved, we can put the solution into the respective truss member. The arrow must be drawn correctly, with inward to the joint shows compressive force and outward shows the tension force. Next, we can analyze joint B, and the similar procedure applies. Note that in this case, the axes X and Y have changed. This arrangement may make the solution easier. We will continue with solving joint C, joint D, and for joint E, please pause your screen and have a try before I show you the answer. Well done! This is the solution for joint E. As you can see, now we have solved all the unknown forces. In order to verify the answer is correct, we can do a quick check at joint. Now we can draw the free body diagram with all the forces obtained at this joint, and by applying either summation Fx or Fy. The calculation should show that the joint has achieved the equilibrium, which in this case, we use the summation Fy equal to 0 to prove that. In summary, we can present the axial forces of the truss member through a diagram. I hope this video is useful to you and see you in my next video.